Okay, the radical stuff. Okay, so multiplying radicals. This is a binomial, this is a binomial, so you need to do a FOIL. Okay, so remember whole numbers and radicals, separating them. So this one would be 3 root 2. Outsides, 3 times negative 6, negative 18. Insides, the whole number is 4, and the radical is 10. You see it? 4 outside, root 10. The last outside would be minus 24, root 5. Can you put anything together on that when you're done? Is anything the same? No. Good. Okay. Sometimes I try to trick you with this question. What happens when you see something squared? Binomial squared. What is the strategy? To repeat its multiplication. Please write it out twice. Don't try to square this and square that. It's not individuals. It's a grouping that you're squaring. It's not individuals squared. Okay, and then start the FOIL process. Go ahead. Okay, there's 3 things you are going to have to do to finish this off, because I'm going to ask for simplified. So one thing you have to recognize is the root of 9 should not stay that way. Some of you did this on your test. You left a square root of whatever, 81 or 16. So the square root of 9 should be a 3, which means I can combine these, because there's just numbers. So that would be 52. And these can go together because they're root 3's and more root 3's. So 14 root 3. Root 3's can go with more root 3's. Okay, breaking down a radical. So what you do is you try to tell yourself, what kind of perfect square can I divide? So do you know your perfect squares in your head? 4, 9, 16, 25, 36. Got it? What is 18 divisible by? And I want to pick the largest one I possibly can. So for instance, 80 is divisible by 4, but I don't want that one because I can go bigger. Do you know which one it would be? 16. 16 times 5 is 80. So now I just put that into radicals. Then, what is the square root of 16? Okay, root 36. Well, that one actually can just go right to a whole number. 45. I have to think of the dividers. So perfect square numbers, what one is divisible by? 45 divided by, what is it, 9 times 5? But there's also a 2, right? There's a 2 in the front, so don't just forget it. It's just there. Then what is the square root of 9? Square root of 9 is 3. So now I can do the whole numbers in the front together. There's a 2 already, and now there's a 3. So 6 root 5. And then I can combine stuff around, so what do I got? 10 of those root 5s. All this is flooding back into your brain, right? Recognizing it. Okay, 2 more questions. Rationalize the denominator. What does that mean? It means that your final answer is not allowed to have a radical in the bottom at all. Okay, so how do I get rid of them? If there's a singlet on the bottom, I would times by a singlet. But this is a binomial. So there was a special multiplier to help get that out. It was a really weird word, and it started with a C. How many remember that? What? Convoluted? So close-ish? What? Conjugate, yeah. Candy. Candy were the answer. Oh, that was a good throw. Conjugate. So, okay, now we know the name. How do you write a conjugate? Same stuff, opposite. Like a difference of squares kind of idea. Plus, minus. One has to have a plus in the middle, one has to have a minus. If you do something to the bottom, you got to do it to the top because you can't maneuver the number. Okay, so now let's do the top. The top would look like this. I need to do the multiplying like that. So this would be what? 6 radical 5. 6 radical 5. Minus 3 out front radical 15. Okay, so now the bottom. 2 and 2 means I would have to do a FOIL, right? But there's something special about conjugates. Do you remember what's a nice shortcut? Those will cancel. That's why that plus minus would cause that cancel. So you can shortcut it. You can flip. Okay, so what's 2 times 2 in the front? 4. There's always a subtract sign. Always, right? Because there's a plus and a minus involved. What is root 3, root 3? 3. Do you remember that? Root 50 is now just 50, right? And then what does the bottom make? 1. So I'm not even going to write the bottom because it says divide by 1. Okay, energy for one more today. Okay, so radical equation. What's your instinct telling you to start with here? Move that out. Yep, that's a good instinct. Okay, so this will have to say x plus 4. Those can't be put together, right? Now, what's your next algebraic instinct? To square both sides? Is that what you're thinking? Okay, remember what this would be. Are you squaring things individually or are you squaring the whole side? You're squaring it as a side. You're squaring the whole thing. So really, that's the process, right? You're squaring it. Not individuals, you're squaring the unit. Square, square root, that's nice. Cancel. Okay, this should be faster for you now because you know all those, it doubles to the middle, squares to the outside, right? Perfect squares, double to the middle, square to the outside.
Okay, Fred.
We've worked a lot with completing the square. That's what that would be. Now what? Algebra. I see x squareds, I see x's. So what's my instinct? I need that now. That's my next. As soon as I see x squareds and x's, you gotta have a 0. Now, you look for your other strategies. Does it factor? Do I have to use the formula? So this should factor multiples of 10 to add to 7. Okay, do not stop there though. There's something else. Check it. With radicals, they're tricky, right? Because you can't just square root anything. So you have to be careful here. So let's plug in a -5. So here's my check. I'm going to plug in a -5 and see what happens. Okay, so here I go. The square root of 1 minus 4. 1 minus 4. What do you think about that? Not working out. So I'm going to cross that one off. Okay, now I'm going to replace x with a -2 and see what happens. So this is the square root of 4. Two minus 4 equals -2. What am I thinking? That one looks good.